Hi friends, today we're going to start talking about factoring. Now factoring is one of the most important skills you need for college algebra. It comes up over and over again. And so it is worthwhile to get really comfortable with factoring because it makes everything else for the rest of the semester a lot easier. So when we talk about factoring, let's talk about what that means. When we talk about factoring, that means that we want to write an expression as multiplication. Okay? If we were dealing with numbers and we talked about factoring, we would say 10 is maybe 5 times 2. We are writing something as multiplication, as its factors multiplied together. One way we can think about it, though, is the opposite of something. Now, when we talked about order of operations, we did distribution. So we did something maybe like 3 times, parentheses, x minus 1, and you know that that 3 on the outside means we're going to distribute the 3 to both the x and the negative 1, and we'll rewrite that as 3x minus 3. So factoring is the opposite of distributing. Especially when we're talking about the greatest common factor. So this video will be the first in a series of factoring videos. And the first thing we always want to look at when we are factoring is looking for a greatest common factor. So a factor that is shared across the terms that we are trying to factor. In this situation, 3x minus 3 has a greatest common factor of 3. So if we were to start with 3x minus 3, identify that 3x and negative 3 have a common factor of 3, we could rewrite it, writing down that greatest common factor one time on the outside, 3, and then writing what's left on the inside. So that if we were to multiply it and go backwards, 3 times x gives us 3x. 3 times negative 1 is negative 3. Think of factoring as an organizing system for an expression. It's just a way of writing it differently in order to simplify or do other things with it. All right, so GCF is the starting place for all factoring. And that's so important, I'm going to pick up a different marker for it. So GCF, greatest common factor, is our starting place for all factoring. So it is the first thing I want to think about anytime I am factoring is looking at all terms, what do they share? All right, so let's look at a couple of examples of using the GCF to factor. All right, let's work through these examples. So for each one, we are trying to factor. We're writing it as multiplication. In this situation, we have 2 terms subtracted from one another. We're going to rewrite it as 2 things being multiplied by one another. All right, so first I want to look at both terms and think about what factors they have in common. So 20 can be divided by 5. 45 can also be divided by 5. Notice this term has an x and this one does not. So they do not have an x in common. The only thing I can pull to the outside is that factor of 5. So I'm going to write the 5 on the outside, and then inside those parentheses, I'm going to write what is left if we divided each term by 5. So 20x divided by 5 gives me 4x. And then 45 divided by 5 is 9, and we'll keep that minus sign in the middle so that I have 5 times parentheses 4x minus 9. Now, if I wanted to check myself, I could multiply it back in to make sure that I got 20x minus 45, which I do. But my answer, my factored form, would be the 5 times parentheses 4x minus 9. And I would want to check and make sure that 4x and 9 didn't have any remaining common factors. They don't, but it's always good to check in case you didn't factor enough out, and then you could go back and start again. Let's try another one. So up here I have 2x squared plus 10x, and I want to look at both terms and think about what they share. Now I'm going to look at the numbers first. 2 and 10, they both have a factor of 2. So I'll need to factor out a 2 for the GCF, but let's take a look at those variables. I have x squared and x to the first power. We don't write that one, it's a sneaky one, but it's there anyway. So x squared and x to the first power, they share a factor of x. They both have an x. Now, x squared has an additional x, but they both have an x. That's what they have in common. All right, so I'm going to factor out a 2x to the outside, and then I'll open those parentheses and write down what would be left. So if I take 2x squared and I factor off a 2x, or I divide by 2x, I get x, because 2x times x gives me 2x squared. All right, if I take 10x and I divide by 2x, I'm just left with a positive 5, because 5 times 2x gives me 10x. And if I wanted to check, I could multiply this back out. 2x times x gives me 2x squared. 2x times 5 gives me 10x. But my answer would be 2x times parentheses x plus 5. All right, let's look at another one. 36x minus 12x squared. Well, 36 and 12, they have several common factors. They have a common factor of 2, of 4, of 6, and 12. We want to take the largest, the greatest common factor that they share. So the greatest common factor between 36 and 12 would be 12. Next, we'll look at those variables. So x to the first and x squared, just like the problem above, they both have an x. This one has an x squared, but they both have an x. So we'll factor an x out. So I have 12x written down as my greatest common factor. I'm going to open parentheses and then write down what's left. So 36x divided by 12x leaves me 3. Another way to think of that is 12x times 3 gives me 36x. And then 12x squared divided by 12x leaves me with an x. So my factored form is 12x times 3 minus x. All right, now sometimes we have more than one variable. You notice in these problems up here, we dealt with the numbers first, then the x's. If there's more than one variable, we'll deal with that other variable after the x's. So numbers first, first variable, second variable, could be third. We'd keep going. All right, numbers first, 10 and 4. Well, they share a factor of 2. So for the number piece, I'm going to factor out a 2. X to the first power. Oh, I don't think I read the problem. Hold on, let me go back and do that. We want to factor 10xy plus 4xy squared. All right, now we're back on track. So we factored off the 2 that they share. They both have an x to the first power, so I'm just going to factor off an x. And then we have y to the first power in the first term and y to the second power in the second term. they both have a y in common. So my greatest common factor that I'll factor out is 2xy. Then we'll open parentheses and write down what's left. So 10xy divided by 2xy leaves me with 5. We'll write down that plus, and then 4xy squared divided by 2xy. I'll be left with a 2, the x's will cancel, and a y. So my factored form would be 2xy times parentheses 5 plus 2y. And if you wanted to check it by multiplying back in by distributing that 2xy, you absolutely could. All right, one more. For this one, we want to factor 3x squared y plus 12x. All right. Again, numbers first. 3 and 12 share a factor of 3. So my GCF and the number part would be 3. X squared and x to the first power, they share an x. And then 3x squared y has a y. The other one doesn't. So I cannot factor out a y piece because they don't have a y in common. All right, so my GCF would be 3x. I'll open those parentheses, and we'll write down what would be left when we factored out the 3x. So we have 3x squared y divided by 3x leaves me with an xy. Keep that plus. 12x divided by 3x just leaves us with 4. So my factored form would be 3x times parentheses xy plus 4. Now, there is a common mistake that people make, and I just want to caution you about that. So let's just think about when we'll do the 12x. So when we are thinking about 12x divided by 3x, remember that these x's are going to cancel out, and we are just going to be left with a 4. So a common mistake is to leave that x there. Remember, if you have x divided by x, it's 1, no x's. So just a cautionary tale there to be careful about. All right, so GCF is a starting place for all factoring. It's the first step no matter what. In the next video, we're going to start talking about some specific techniques that you'll use in different situations based on the polynomial you're trying to factor.